Testing 1, 2, 3. Can you hear me? Testing 1, 2, 3. Can you hear me? Okay, before we start, in this lecture here, we're going to discuss on the set questions for KMS. And I try not to spend too much time on explain concept here, but we rather go direct on how to get the answer for the question so that we can save more time and you won't get too bored with this long video here. And now let us begin with the first question. In section A, in part A, question 1 given that two events M and W are such that PM is 0.3, then PW given M is 0.5, and PW given M prime is equal to 0.25. Find the following. So how do we get this answer here? Let's have a look. First of all, in my solutions here, I just summarized the informations that already given to me, where the PM and the two conditional probability as below as reference. And this is not compulsory step to do. So let me have it written in red. This is not compulsory step, just for us to refer. Okay, now first one. If I want to have the answer for P intersect W, so what I will need to do is that I just need to use PM multiply with the conditional probability PW given by M. And how I can do such thing is that if we refer to the definition of PW given by M, this is what happened. The intersection divided by PM. We rearrange these equations here. You will happen to find out the intersection between W and M equals to PM multiply the conditional probability. And for the intersections, whether M come first or W come first, it doesn't matter. So these two are referring to the same thing. And as a result, this is how I get the formula. So for probability PM intersect W, I can just use PM 0.3 multiply with PW given by M 0.5. As a result, I have the answer equals to 0.15. So this is for question A. Next, for question B, we are going to do the similar thing where we make use of another conditional probabilities that is given in the question. So in this case here, another conditional probability given to us is this one. And based on the same idea, this is how we find out for the result where we can find PM prime intersect W is given by PM prime multiplied with the conditional probability W given by M prime. And therefore, with this idea here, I can have the result as follow. PM prime multiply PW given by M prime. And in here, please take notes. How we happen to calculate for the PM prime here? PM prime is just equals to 1 minus PM. And in this case here, your PM is equal to 0.3. 1 minus, it gives us 0.7. Multiply with the conditional probability, 0.25. It gives us the result, 0.175. Okay. Next, C. When the time we want to find PW, in these questions here, we find out that our PW is happen in two type of situation. One of the situation is that we have it as PM intersect with W. The other one is PM prime intersect with W, which is the result that we have in part A and part B. So when the time we calculate PW, we sum up these two probability from part A and part B. Therefore, we have 0.15 from part A, 0.175 from part B. Sum up, it gives us 0.325. Then D, part D, the answers to state reason why event M and W are not are independent. So, are dependents. Are dependents here? That means we are referring to the event such that they are not independent. In other words, it's referred to not independence. So when the time you're talking about independence or not, what we want to check is we want to check about these situations here. Whether the intersections of these two events are they happen to be the same as the multiplications of the probability of PM and also PW. Are they happen to be the same? I put question mark there because it's not yet proven they are the same. We need to investigate to find out. So in these questions here, you don't have to calculate the intersection anymore for part D, in part D because we already have the result in part A. We're just going to make use of the result in part A as reference later. What we need to do now is that we try to calculate the multiplication of PM and PW, then we compare with the result in part A. So therefore, we proceed with our solution. We try to calculate out PM multiply PW. We will have it as 0.3 multiply 0.325, where 0.325 is the result we have from part C. We just find out just now. Whereas 0.3 is already given in the questions. It's already given in the questions. And by the time we press calculator for answer, you find out that the product will give us 0.0975. And compare this result with the intersections between M and W, which is the result in part A. What you find out is that in part A, you have the answer as 0.15. Obviously, these two answer, 0.15 and 0.0975, they are not the same. So therefore, with these observations here, we can state the conclusion with reason as follow. Where we start with the reason, we say, we notice that PM multiply PW is not the same as PM intersect W, and therefore, the events M and W are dependent, or in other words, they are not independent. So this is how we have the answer for question number 1D. Okay. Next, we will go on further with the solution for question number 2 in part A. And let's just have a quick look on the questions before we answer. So a fair dice is thrown and the result is observed. If the outcome is 1, the dice is thrown once again. And the random variable x is the sum of the two throw. If the score is 2 or more, then x is the number of score on the uppermost surface of the dice. Construct the probability distributions table for x. So in this case here, in order to solve part A, first we need to be clear about what is the x referring to. So basically what we happen to find out is that x is the score that we happen to obtain when the time you throw a dice. And when the time you throw a dice, whenever we talk about dice, we happen to consider a normal dice, which is happen to be a cube, where we have 6 surface, number as 1 until 6. So when the time we throw a dice, what will happen is that, okay, let us try to draw a tree diagram, which is not compulsory to analyze these situations here. So guys and girls, first of all, when the time you throw a dice, you will happen to have 6 possible outcome where you can have the number obtained as 1, 2, 3, 4, 5, and also 6. And this branch here I draw in red is happen to be the first throw, bila you throw for the first time. And the probabilities for each of the outcomes here from 1 until 6 in red. According to the question, you was told that it's a fair dice. So all of them will happen to have the same probability where I have 1 over 6 to get 1, 1 over 6, 1 over 6, 1 over 6 for each one of them. Then next, what you happen to find out is that if let's say I get the result when the time I throw the dice, I get the result is 1, the score is 1. Then what I need to do according to the question, if the outcome is 1, the dice is thrown once again. So if throw once again, now I continue the 3 diagrams from 1. Again, I can have the possible outcome as I may get 1, I may get 2, I may get 3, I may get 4, I may get 5, and I may get 6. So this is what happens in the result. And with that, next, if the score is 2 or more, that means the rest of this 2, 3, 4, 5, 6. Then what we do is that we doesn't throw another time, but we just come to conclusion, what is the score referring to? So let's see now. The X is referred to the end score that we have. And let us try to analyze for each of the situations here. So if the outcome is 1, the dice will happen to be thrown 2 times, where the first outcome is 1, the second outcomes, it can be 1 until 6. And the result will happens to be the X value is the sum of the 2 throw. So the first throw is 1. Therefore, for this case here, the X will be first throw is 1, second throw is 1, so outcome is 2. The next case, I have X equals to 1 plus 2. First throw is 1, second throw is 2, I have 3. Followed by 1 plus 3, I get 4. Second throw is 4, so 1 plus 4 is equals to 5. 1 plus 5 is equals to 6. Then I have X equals to 1 plus 6 equals to 7. This is what happened if I happen to get the score 1 and I need to throw one more time. So the outcomes of X will be sum up these two, the one in red and also the rest of the number in green here. Whereas if let's say the outcomes is not 1, 2 and more, which is referred to 2, 3, 4, 5, 6. What will happen to be the outcomes now is that you'll find out it will just direct to the number that you see, which is if you throw, you get 2, so X equals to 2, X equals to 3, X equals to 4, X equals to 5, X equals to 6. So basically, this is what we happen to see. And again, this tree diagram is actually not compulsory step, just for you to have the idea how the thing's going on. Of course, if you're able to observe the X value without referring to the tree diagram, then it's all right. You don't have to sketch this tree diagram. It's not compulsory step. Okay. So basically, from these three diagrams here, you can roughly see that the highest and the lowest X value that we can have in this X here, it will be happen to be lowest X equals to 2, highest X equals to 7. So later in the value that you have highest is 2, sorry, lowest is 2, highest is 7, and in between them, as you can see, we have 3, 4, 5, 6. So 3, 4, 5, 6. So we have the X as 2, 3, 4, 5, 6. After we identify the X value, the next thing what we do is that we try to calculate the corresponding probabilities. And how we get the answer of the probability, please be careful in your calculations here. So guys and girls, if you notice, for the time you get X equals to 2, it can happen in two types of situation, where in the first row, you directly get 2. Or it can happen in the way that you need to go through 2 rows. That means first time get 1, second time get 1, in order to get x equals to 2. And the sum of these two probability will be the result for my probability of x equals to 2. And by the way, just now I forgot to mention, the probability of getting 1 until 6 for this one in green, it will also happen to be 1 over 6, 1 over 6, 1 over 6, because we are still referring to a fair dice. And this result for the second row, it won't be affected by the first row. It won't affect the percentage, or it won't affect the probability for getting any of these numbers here in the second row. So therefore, let me go for further calculation at the side before we refer back to the table. So in this case here, what you happen to find out is that in order to get px equals to 2, you will happen to have two situations. The first situation is that you directly have 2, which the probability is 1 over 6, where this one is the one that I highlighted in red. The one I highlighted in red. Plus with the second case that I can get to is that by the time I have 2 thrown, which is the one that I highlighted in green now, where it will happen in the case of 1 over 6 multiply 1 over 6, where the first 1 over 6 is referring to the probability getting 1 in red. The next 1 over 6 is that getting the second one in green here. So as a result, you happen to find out that I have the answer. If you just have a quick calculation from your calculator, I have 7 over 36. So this is how I happen to get my px equals to 2. Similarly, when the time you consider for the case of x equals to 3, it will happen in the same trend, where I can have directly x equals to 3 when the time my first row I get the result, the score as 3, or I can have a second type of outcomes where the first row I get 1, followed by the second row I get 2. So this is what happened lah. Let me this time highlight everything in purple. So direct get x equals to 3, or go through x equals to go through 1, and then followed by go through 2, followed by getting the dice result as 2. So 1 plus 2, I get my 3 here. And this will happens to give me the result as 7 over 36. And you happen to find out now, the same way of calculation will occur from the value of x equal to until x equals to 6, because you find out that from x equals to 2 until x equals to 6, it happens to occur in 2 situations. Therefore, in the table here, we will have start from x equals to 2, 7 over 36, until x equals to 6. Whereas for x equal to 7, we just happen to follow getting, you only have one path to go through, where you must get 1 first, followed by getting 6. So the probability will be just 1 over 6 multiply 1 over 6, and it gives us 1 over 36. And that completes our table. So this will happen to be our probability distribution table. Again, this table here by right lah, you don't have to show any calculation pun boleh lah. Asalkan you dapat tulis keluar jadual ini dengan betul, then it's alright. And please be aware in your writing, make sure this part here, the small x and capital X, we can see there's a difference lah, where the one behind here I highlight is should be small x. So do this one. It should be a small letter x, where the place that we're going to substitute with numbers in some calculations. Go on. Once we get this thing here done, part B, they ask us to write down the cumulative distribution of the function x. So how we do that? So guys and girls, in here, if you see my solution, I will begin the solution with a table, where my table, I have X, the probability that we calculate just now, and also my cumulative capital F. I redraw this table here at bottom so that I don't want my answer in part A being disturbed. So that I won't kena penalize lah. So saya buat kiraan yang baru untuk part B. Jangan you terus conteng di atas lah. Okay. Anyway, this new table here that I written in blue is not a compulsory step because some of you are able to just directly observe the capital F based on inspection. You're just able to observe the value by inspection. So anyway, just in case you can't see what I do by inspection, so I redraw the table. Again, this table in blue here, written in blue, is not compulsory. Kalau you boleh nampak terus, then go ahead for the function. Okay, so let's see. How we construct the capital F is that, okay, we start with the first value of X, 7/36. Usually the first value, the P and the capital F will be the same. So here will be 7/36. Follow? The second value for capital F, how we're going to do the calculation is that we're going to consider, we take these two values, we kita plus. So we find out that you have 14/36. In here, in the table, I doesn't simplify my answer. So that if let's say I use my calculation, I use by inspection untuk kira, tak mau guna calculator, by right, I can calculate easily lah. If you need to simplify the answer, it's all right, but I want to make easy to calculate. And furthermore, this is not the final answer yet. So it's all right, I keep in not simplified form. Follow the next one. Consider these two values. Again, I sum up. So I have 7/36 plus 14/36, 21/36. Similar idea. Sum up 7/36 and 21/36. It gives me 28/36. Sum up further 7/36 and 28/36, 35/36. And lastly, sum up, it should give me 1. So this is the table that we use as a guideline to form our cumulative functions. Okay, once we're done with this table here now, what I'm going to do is that by referring to the table here, we're going to construct our cumulative function. Okay, let me wrap off the work that we have draw on top of it just now. So now when the time I want to consider for my cumulative function, what I need to focus is that I just need to focus on the capital F and also the small letter x value, like this saja. The P saya padamkan dia supaya tak kacau kita punya observations. So how we're going to do is that, first of all, you must always alert that your cumulative is always happen to be from 0 until 1, So therefore, for your cumulative function, without further ado, you know that you start from 0 until 1, like this. Go on. Then what is the interval for corresponding 0 and 1? Maybe this one we have difficulty. So usually the first and the last, which is 0 and 1, saya tak akan tulis dulu. I start from the second value, the value after 0. Where the value after 0, it will happen to be refer to this one. Refer to this one. 7/36. So therefore, the second value I have 7/36. 7/36. And what is the corresponding interval for 7/36 is that, guys and girls, pay attention here. In table, you see 7/36 is under 2. So it's under 2. And when the time it reach the next value 3, it will change to another capital F. So from here, it gives us the idea that for 7 over 36, I'm going to consider start from 2 until somewhere before I reach the next value, somewhere before I reach 3. So in order to indicate that, my interval will be 2 less than equal x less than 3. Start from 2 and before I reach 3. I must exclude 3 because if I include 3, by right 3 should read a new value of the capital F. Okay, then go on. For the next value, 14 over 36, and we simplify it, you have 7 over 18. Then how we get this answer here is that we're going to consider start from 3 until somewhere before 4. So start from 3 until somewhere before 4. It will be 3 less than equal x less than 4. Follow? 21 over 36 is the next value. When the time you simplify, you have 7 over 12. In the function here, we must simplify. And how you define for this one, 21 over 36, you will start from 4 until somewhere before you reach 5. We exclude 5 is because once start 5, we shall read the new fx value. So therefore, if you know it start from 4 before you reach 5, so this is the answer we have. 4 less than equal x less than 5. Same idea, from 5 until before 6, I have 28 over 36. 28 over 36, when the time you simplify, I have 7 over 9. So 7 over 9 is start from 5 and before you reach 6. Start from 5 before you reach 6. Follow? When the time you have the case of 35 over 36, which x value before you reach 1, it will happen to be from 6 until somewhere before 7. So 6 less than equal x less than 7, not include 7. Then finally 1, what you see here is that it will happen to be 7 and onwards for your x. Therefore, x greater equals to 7. After you complete all this, now we back to 0. So 0 will happen to be from negative infinity until somewhere before 2. So maybe you can also treat in the way that you add in the extra cumulative 0 here, where you happen to tell yourself that we always consider from infinity. So from infinity until somewhere before 2. So this is the result. And therefore, we have complete our cumulative. Go on. To determine the median, 1 marks only given. 1 marks, that means usually the answer, you don't have any calculation or the calculation is very simple, can be done by inspection. So in this case here, we often being told that if you want to find median, we consider the case of cumulative FM equals to 0.5. But however, if let's say in our situations where we don't have FM equals to 0.5, the cumulative equals to 0.5, what we do is that, like what is stated here in my solution, if capital Fx equals to 0.5 does not exist, let us refer to the x value such that the Fx is greater than 0.5 for the very first time. And now we make use of our cumulative functions. So let us refer to the one on top here. So again, I erase the trace that I have for the previous question. Let's see. We notice that if I want to have greater than 0.5, you will find out that obviously 0 cannot be greater than 0.5. 7 over 36 also no. 7 over 18 no. 7 over 12. You find out that this is the one that greater than 0.5. 7 over 9 greater than 0.5, greater than 0.5, greater than 0.5. You notice that we start to have capital F greater than 0.5 at this point here, where for the very first time we have greater than 0.5 is the value of 7 over 12. And in 7 over 12, the corresponding x value we have is 4. So all this is just happened by inspection, dengan tengok-tengok saja. Then we come up with the answer. So x equals to 4 as our result. As simple as that. Tak ada kiraan, sekadar tengok-tengok saja. Next, D. We want to find the probability for P2 less than X less than 5. And please take notes, ada pembetulan sikit pada tulisan sini. By right, this is capital letter X. Okay. So, how to get this answer here? So, by right, you boleh pakai dua-dua cara guna your probability function. You can also use your cumulative. And in this case here, I want to make use of the cumulative. Since saya sudah ada cumulative, so I refer kepada cumulative. So that all the time my calculation is always one capital F minus another capital F. Okay. So guys and girls, if you want to make use of cumulative function, you must alert on one thing here, which is the definition of cumulative. Let's say I have F M. This is referred to the probability such that X less than equals to M. I must always consider this thing here for my calculations. So, by the way, when the time we have such inequalities, maybe some of you happens to have the concept of memorizing such that you have P, let's say A less than X less than equals to B. Then what we do is that we just use FB minus FA with the condition such that behind had equal, in front no equal. So maybe if you memorize this formula, you just need to do adjustment like what I do here. Where if behind here, I want to adjust to less than equal. So less than equal will happen to turn to have less than 5 become less than equal 4. And therefore, using the formula I have here, I will have F4 minus F2. Where is F4 referring to? F4 is referring to this one, where it happens to give me F4 as 7 over 12, whereas F2, it will refer to this value here in your cumulative function. So I have 7 over 36. And as a result, I have the answer as 7 over 18. Okay, so this is how we get the answer. Of course, again, we have not only this way of solution, we can also consider, let's say I show you another alternative solution, where if let's say I don't have the idea of memorizing any formula, and this way we can always do it for the case of discrete. So guys and girls, what I need to consider is that if I want to make use of cumulative, where I want to make use of F minus F to get my answer in this case here, I need to consider the definitions. This is minus less than equal. And what we're going to fill in for this thing here is that, okay, consider inside this interval here, what is the corresponding X value that we have? You have 3, not include 2, so you have 3, you have 4, 5 not include. How can you ensure that you have this minus here, that you have 3 and 4? So guys and girls, in this case here, if you want to use X less than equal, so the first less than equal, we will consider the largest value that we have in the list. So I will have less than equal to 4. That means I start from F4. Then next, consider for the case of X less than equals to 4. What you have when the time you have less than equals to 4? That means you start from 4, decrease, become 3, 2, 1, so on so forth. If there is possible more value behind lah. But guys and girls, The actual list I want is just that I want 3 and 4. I don't want the rest of the thing in front of 3. So therefore, I need to exclude this part that I have in green. So in order to exclude that, I minus less than equals to 2. So therefore, it comes with the answer of F4 minus F2 as well. And it leads to the same result as the other side. But just that you don't have to memorize, what formula to use in the case of less than and less than equal. Of course, it depends which one is easier for you. Then go ahead, both of the methods is acceptable. But they give us the same result. Next, E. E, in this case here, again, there is a typing error. It should be capital X here, not supposed to be small letter X. So how to get this answer here? Again, you can make use of your probability function. You can make use of your cumulative. And if let's say in this case here, I want to make use of my cumulative. So again, cumulative, we're going to have the definition where I want to consider X less than equal. So in order to have less than equal so that I can use capital F, what I do is that I use the idea of 1 minus. And be aware the way I do 1 minus here, where this 1 minus I do is always correct. It's always applicable no matter it's discrete or continuous, where I will have 1 minus the probabilities of the X is still X itself, the 5 will still 5 itself, greater will turn out become less than, and then equal depends. If in the question no equal sign, then our 1 minus we put equal sign. Only one of them will have equal sign. Then from here we see we have Px less than equals to 5, where each minus F5. And in this calculation here, F5 will happen to refer to 7 over 9. So 1 minus 7 over 9, we have 2 over 9 as our answer. So this is how we get for the next question solutions. Continue. We go for part A, question number 3. So in these questions here, they told us that at a restaurant R and S, the number of customers has a Poisson distribution with a mean of 4.5 customers per hour. So in these questions here, they already told us that it's follow Poisson distribution. So obviously it's a chapter 10 questions regards on Poisson distribution. And in this case here, the mean 4.5 happened to tell us the lambda is 4.5. And this 4.5, to be specific, is referred to the case of 1 hour. They say per hour, that means 4.5 for 1 hour. If later in our discussion it's not about 1 hour, then we need to make adjustment accordingly for the lambda. Okay, go on. Part A. Find the probability that exactly 8 customers dine in during the first hour. Part 2. From 10 to 14 customers dine in from 9 until 10. Less than 5 customers dine in for the first 30 minutes. So what we happen to find here is that what we want to discuss, the probability is discussed that how many customers. So in fact, if you notice, dia sudah terang-terang beritahu kamu di sini, the number of customer has a Poisson distribution where it happens to tell us the number of customer is referring to the X value we have. So therefore, in here, I will start my solution with defining the X as the number of customer dine in. Because here discuss about how many customer dine in. And what I written in red is lambda equals to 4.5 for 1 hour. This one you don't have to state down, but you just need to take notes and alert. And now we're going to solve for each of this case here. Okay. So first case, if I have exactly 8 customer dine in, so if I have exactly 8 customer dine in, that means that I'm referring to the case that I want to find Px equals to 8. Px equals to 8, where we talk about 8 customer. But in Poisson distribution, please be alert. This 8 customer, we want to discuss in what time interval. So they say during first hour. So that means I want to talk about in the time frame of 1 hour. In the time frame of 1 hour, so my lambda will be 4.5. So I'm going to consider x equals to 8, the probability, based on lambda is 4.5 in these questions here. Go on. When we have x equals to 8, it's up to your choice. You want to use formula or you want to use table. And let's say now I want to make use of table. X equals to 8 will be greater equals to 8 minus greater equals to 9. We use greater equal in this case here because the statistical table gives us greater equals to 8, greater equals to 9 value. The table always gives us x greater equal value, no matter it's binomial or Poisson. In fact, normal also we can consider the same thing. We always have the case of greater equal. Go on. Continue. Based on statistical table, I find out that my p greater equals to 8 and greater equals to 9 as following. For the case of lambda as 4.5, use our calculator to minus. I have my answer as 0.0463. Go on. Part 2 of the question. We still discuss our x is topic on number of people, and please take notes on one thing lah. As usual, like in my class, when the time I define Poisson, I just tell the numbering of the occurrence. I doesn't tell the time period in my definition of x, because I will just state the time frame or the space inside my distribution later, like what I have here in 1 hour and later in a particular time. Okay, go on. For part 2, from 10 to 14 customer. So from 10 to 14 customer, so this probability will refer to probability 10 less than equals to x less than equals to 14. We have equal sign because include 10, include 14. And in this case here, what is the x follow, what is the lambda referring to? We already know it's Poisson, but in this case of Poisson, it happen to be have lambda or how much? Let's see the time frame that we have, 9 to 10 o'clock. So in here, we find out that we have 1 hour. So if we discuss about 1 hour, so in 1 hour, lambda is still 4.5. And in order to calculate this answer using table, we are not going to list out from 10 until 14 by using formula, but we're going to make use of table. So guys and girls, just have a quick look. Whenever you want to make use of a table, you are actually doing the calculation such that you have px greater equal to something minus px greater equal to another thing. And what is the value that we want to have the greater equal here is that, okay, guys and girls, again, we are going to do the case of x greater equal minus x greater equal. And what is the value we're going to have here is that, let's see, the value we want is that we want from 10, 11, 12, 13, 14. We want until 14. And how we get the answer to fill in for this case here is that in the list that we happens to have here, let's see what is the smallest value I have. For greater equal, we use the smallest value. So I have 10 as the smallest value. So I will have x greater equals to 10 minus something. The minus something is the extra part that I don't want. And if you notice, when the time you have x greater equals to 10, it means that we have 10, 11, 12, 13, 14, 15, so on and so forth. And it's not this list of number for x greater equal to 10. I just want to until 14. The rest from 15 and onwards, saya tak mau. So, bahagian yang you tak mau, 15 and onwards. So we have x greater than equal to 15 that we are going to minus. Followed by statistical table for the case of 4.5. This is the result we happen to have. we have x greater equals to 10 with lambda of 4.5. The probability is 0.01. For the case of x greater equal to 15, we got 0.001. And as a result of the subtractions, you find out that we have the answer as 0.0170. Okay, next. Part 3, still talking about how many customers there, but be aware, this time the time frame had changed. Anyway, let us see. We want to find the probability such that we have less than 5 customers. So that means we are looking for the probability such that x less than 5. Excited to do calculations then. Let us be aware, what is the time frame now? It's referred to the time frame of 20 minutes. Lambda 4.5 is happened for the case of 1 hour. So lambda 4.5 for the case of 1 hour, which is happened to be 60 minutes. And now if I want to refer to 20 minutes, what is the corresponding lambda here? So this is just simple maths calculation. From 60, you want to turn into 20, we divide by 3. So the same thing, the lambda 4.5, we're going to divide by 3, and this gives us the distribution as 1.5 for the time period of 20 minutes. So later, when the time you refer to table for answer, we refer to lambda 1.5. Go on. Given in the question is x less than 5, but if you want to use table, you must have greater equal. So in this case here, what we do is we use the 1 minus concept. I have 1 minus p x greater equal to 5. And x greater equals to 5, I have the answer 0.0186. And as a result, to do the subtraction, the probability is 0.9814, just as simple as that. Then follow part B. If x is referred to the number of customers, so guys and girls, part B actually, they redefine the x, but it actually doesn't change much in the situation compared to what we have defined just now. X is referred to the number of customers that dine in, let's say dine in. The lambda is 4.5 for 1 hour. And please be aware, in this question here, is the time frame that we want to use is same as the given one. So they say from 9 p.m. until 1 p.m. And you must take notes in here from 9 to 1 p.m. how many hours there. So by right, from 9 to 10, 1 hour, 10 to 11, 2 hours, 11 to 12, and then 12 to 1, by right, there is 4 hours there. So if 4.5 is for 1 hour, and now we consider a time period of 4 hours, therefore, we will have lambda as 18 for 4 hours. And in these 4 hours, what we're interested to calculate is that we like to calculate these probabilities here. And in order to calculate these probabilities, again, we just have a quick calculations where if we want to make use of table, I must have x greater equal minus x greater equal. And what is the corresponding value for the first and also the second probability x greater equal? We can happen to have the idea in the way that first, what is the x value we want here? We would like to have the x value as start from 21, 22, all the way until 35. I'm not going to list out one by one until 35. I just list out whichever that I happens to be useful to me. So in this list here, we are going to refer to the smallest, which is 22, to fill in for the first place. Then for behind, what we want to minus is that we can consider in such that greater than 21 is referring to 21, 22, all the way 25, 20, 36, 35, 36, so on and so forth. And what actually I need is just that I need this part here I highlight in purple. The extra part I don't need is that from 36 and onwards. So therefore, I'm going to minus greater equals to, sorry, I make a mistake here. I don't want to have 35. I don't want to have 35. I just want until 34. So by right, what I should exclude is that I should exclude some from 35. I should exclude some from 35. Some from 35, I want to exclude. I want until 34 only. So therefore, as a result now, I have the answer as following. 0.2693 minus 0.0002 and answer 0.2691. We don't want 35, so should be minus 35 and onwards. So there goes the 3 questions in part A. Okay, continue. Part B. Part B is chapter 3 questions on numerical methods. In this question here, we're going to test on trapezoidal rules. So I hope that you remember the formula for trapezoidal rules, and hopefully if you don't remember, you understand. If you don't remember, hopefully there is formula given and you understand what is the formula given. Okay, so let's see. First of all, whenever you do trapezoidal rules, you need to identify what is the h, where the h is happen to be the width of the trapezium, the size of the subinterval. And before you can get h, usually I need to know what is the n value, how many subinterval you have. According to this question here, the hinge is referred to 5 ordinance, the 5 ordinance. So if I have 5 ordinance, that means it's going to give me 4 interval, 4 subinterval. And 4 subinterval give us n equals to 4. And how we make use of the n equals to 4 here to calculate h is that I consider the upper bound and lower bound of my integrations. I take the upper bound minus the lower bound, divide by my n. The corresponding result, 0.5, will be the h, the width of the trapezium that we're going to have. Each of the small trapezium we're going to have when the time we break the region into trapezium. Then next, we construct a table in such that I consider the function inside the integral as the function of fx. And if you notice, in my solution here, I happens to construct a table with 3 columns, where the first column regard on x, both of the second and third is referred to fx. And why I want to have 2 columns for fx, 2 different columns, is because they serve a different purpose to find the sum of different items, where this is what happened. Let us fill in one by one, and then only we see the result of fx. And by the way, this table here can be actually obtained from the calculator function, where you construct table in your calculator. But in here, we're not going to discuss about that. Let's see our x value. So our x value, we're going to start from the smallest value that we have in our integral, minus 1. So we start from minus 1. The next value, we take this minus 1 plus the h value, negative 0.5, plus 0.5, plus 0.5, plus 0.5, follow through. So by right, the last value of your refer to the upper bound of the integral, which is 1 in this case here. Okay, go on. Then next, We split the fx into two columns in the table such that one of the column we would like to have the sum of the first and the last x value, the fx value for the first and the last of the x value, which in this case here will happen to be the first value, -1. Substitute into fx by using calculator. I find out that this is the result. And in here, I use 5 decimal places because the final answer require for 4 decimal places. So in our table, we should have 1 extra than it. So final answer 4, we use 5 in our calculations. Follow? So this is the first and last x value. The middle x value, we're going to put in another column. We sum up them separately. And why we want to sum them up separately is because later, when the time we apply trapezoidal rules formula, this is what happening. So recall on the formula, we have h over 2 multiply the first fx value plus the value plus with the multiplication of all the rest middle value yang tengah-tengah punya. So ini adalah first two, this is the middle. So as a result, the sum of the first two value, you will have 2.58144. The middle value, 3.99578. And by the way, we substitute according to this formula. First, h over 2, 0.5 divided by 2. The sum of the first and last value, 2.5 something, plus with 2 times the middle. This whole thing here, you press your calculator in one shot and convert into 4 decimal places. That goes your answer. And in these calculations here, be careful on 2 things. First, about the decimal we're going to use in our calculation. Always 1 extra than the final. Second, when the time you use your calculator for calculating the functions, please make sure you key in the functions correctly lah. Go on. Question number 2. Talk about conic sections. Equation x squared minus 2x minus 6y plus 13 equals 0. Express the equations and identify the types of conics in standard form. Find vertex directrix focus and hence sketch. So let's refer to part A first. What we want in the part A is that we want to have 2 things. The equation in standard form and then identify the types of conics. According to our syllabus, you learn 3 types of conics: circle, ellipse, and parabola. And in this case here, how are we going to know what types of conics is that? Of course, they ask for expressed in standard form. But before you can express into standard form, you must somehow have the idea that which one is it, so that you have a better idea to do the conversion into standard form. So in here, let us have a quick review to see if you happen to face such question, how you determine or how you predict what type of conic is it in our syllabus. So first of all, you need to find out in 2 situations. First, whether I have both x squared and y squared, or have either one. Atau saya tulis lebih ringkas lagi lah. With x squared and y squared. The other one is x squared or y squared. Ini ada dua-dua, sini salah satu. Kalau salah satu, in our syllabus, for sure is parabola sudah. Then kalau ada dua-dua, then we see same coefficient or different coefficient. That means kita cuba tengok you punya x square and y square, adakah dia ada coefficient yang sama. So kalau ada same coefficient for the x square and y square, circle. Coefficient is different, then that is happen to be ellipse. This is the rough idea. At least boleh apply in syllabus kita. By right, untuk part yang atas sini, not if consider overall, because we still have one thing that we didn't learn, which is hyperbola. We need to consider more things lah. Okay. So from this case here, we find out that the equation given to us, we only have x squared. We don't have y. So somehow we know that this is happen to be a case of parabola. So if you know it is parabola, what we're going to do is that we're going to arrange the equation in such that we do completing the square on the x terms, rearrange the equation such that x minus 1 square on one side, the y on the other side. Then next, 6y minus 12, we factorize it. And by the time you factorize, we factorize according to the coefficient of y. Berapa ada pada coefficient pada y, kita factorize semua. Asalkan pastikan you dapat, your bracket here is y saja. Bukan tolak y ke 2y, but y saja dalam bracket. As a result now, we already achieved the standard equation. Now, we write a simple statement. We say that it is a parabola with standard equations, so on and so forth. And by right, your solution to get full marks, you have the calculation step as I highlighted in purple now. Step kiraan ini dengan tulis perkataan cukup untuk markah penuh. But in this answer scheme here, I write in full sentence lah for better understanding. Once we're done with this thing here, part B, we want to find vertex, directrix, and also the focus. So this one, how we get this answer here, we start with the compare with x minus h squared equals to 4p y minus k. We compare the standard with this one, where you find out that the hk is referred to the vertex value. Directrix and focus, I need to find out what is the corresponding p value first. So your p value can obtain from by comparing 6 and also 4p, and it gives us p equals to 3/2. For vertex, it's referred to h. So you compare the equation, you find out vertex is 1 and 2. X equals to 1, y equals to 2. Then follow, next part, be aware. Directrix and focus, we notice that it happened to be plus minus of p, the vertex. Tapi your plus minus p kan adalah pada x atau pada y, itu adalah satu masalah yang you perlu take notes. So let's see what is the information that can tell us on the p here to help us to decide how we get our directrix and also focus. So first of all, we notice that this is the case that we have x. That means your parabola is either a smiling face or a sad face. That's the first thing. Next, when the time you have p is happen to be positive. So for p is positive, we are referring to the case of smiling face. And here I notice that if this is the location of my vertex, my focus is somewhere inside here, and the directrix is below. And what you can see now is that focus and vertex in our understanding, they should be located in the same vertical line. If they located in the same vertical line, what you find out for your focus and also vertex is that they have a common x value. So from there, we happen to find out that if I happen to have a common x value, my focus, I have x coordinate as 1. Then how about my y coordinate? So take notes, for parabola, focus, you always have plus p, directrix, you minus p. So focus, you plus p, the y, you plus p, so you have 3/2 plus p. I get 7/2. Directrix is always minus p. We take our y minus p, so 2 minus p, we have y equals to our result. And then nothing much, we just sketch the diagram. Make sure you do label your x and the software I use here, it doesn't label the x and y axis. Make sure you label the focus, vertex, as well as the directrix. So this is happen to be our diagram. Question 3. Question 3. We have a point of R and S, which is the endpoint of diameter of the circle. Then equation of the circle in standard and general form. B, the equation of tangents to the circle at point R. So first of all, let us try to understand the situation by a rough sketching. We try to sketch a rough diagram to understand what is going on. So what we have is that we happen to have a circle that we don't know the equation. Sure, we have a center. Then we have 2 points there, R and also S. Let us simply draw the point. Let's say here is R, here is S. And by the time I connect R and S, this diameter where it will pass through the center. So this is a scenario that will happen according to the questions of the circle. Then now we want to obtain the equation of the circle, whether it's standard and general form. We know that when the time we want to find the circle equation, we need to know 2 things there, where first is the center, next is the radius. To get the center, we notice that from the diagram, the center is actually the midpoint of R and S. So by using the midpoint formula, we get our center. To get our answer for radius, what we have is that, so be aware, your radius is actually equals to of your length of the line RS. And therefore, how we calculate the length of the line RS is square roots of, I use point S minus, I consider point S minus point R. I'm considering using point S, point R minus point S to get the result follow. And don't forget the 1/2 because you're calculating on the radius, and we find out the answer is 5 feet. With the center and radius, we can actually start to see the equations. Then in order to calculate our general equations, what we can do is that we can consider the general equation, this one, x squared plus y squared equals, x squared plus y squared plus 2gx plus 2fy equals to 0, where the center gives us the corresponding value of f and g in such way. Then to get the answer for C, we notice that C is actually equals to g squared plus f squared minus r squared. So your g is happen to be minus 2, f is minus 1. is happened to be 5. Then as a result, I have C as negative 20. Information here, my G, again, the better I write it down for better reference. From here, comparison, G is -2, F is -1. So I can get my general equation, substitute according to this formula as the following answer. So this is your This is your 2 times of G, 2 times of. So this is one of the way. Of course, another way you can do is that you expand the standard form to get the general form. But in here, I only show you one of the solutions only. One of the way to solve the questions only. Continue. The next part of the questions, we would like to find out the equations of the tangents to the circle at point R and S. So what happened in this case here is that, see, we have a center, we have a diameter. Here is the location. I suppose I have my R and S. May not be the exact point, but just a rough diagram to help us to see what is going on. What we're interested to find out now is that we would like to find out the tangent at the point R and S, which means that this is what we have. The red line here. I want to find the equation of these two red lines here. And what's the criteria we can make use of is that we notice for this part of the radian, it will happen to be perpendicular to the tangent here. The next part also perpendicular. And actually, the whole blue line here is a straight line, which is in other words, the blue line is perpendicular to both of the tangent. And why we want to emphasize this thing here? So that I can make use of the gradient of the line RS to find the gradient of the tangent that I need later. So, continue. Gradient of RS, we can calculate as follows. Using the difference of y coordinates for R and S, divide by the difference of the coordinates of x for R and S. I divide them. I get -3/4. From there, I find out that the equation of my tangents. So be aware in here, when the time you multiply RS with tangent, I get the answer as -1 because they are perpendicular. So we have this property in calculation. As a result, your MT equals to -1/MRS. And this will give me the following result. Sorry, I think I typed something wrongly here. So I suppose here will be happen to be -1 divided by -3/4. And therefore, it gives me the result of 4/3. And with the tangent as 4/3, and both of the tangent having the same gradient, please take notes. So to calculate the equation for tangent at point R and S, I'm going to make use of this formula where I have my y minus y1 equals to m multiply x minus x1, where your y1 and also x1 is the x and y coordinate corresponding to the point that involved in the. From the R, I have my y as 4, the x as -2. Follow if I present the answer in the form of y equals to mx plus c. Whereas for the case of tangent at the point S, this is the result we have. If I consider to write it in the form of y equals to mx plus c. Go on. Question 4. Question 4, we would like to discuss regards on vector. So the question happened to break into three part A, B, C, and all the three part, it don't seems to be related. They are all independent questions. So let's start from the part A question. You are given vector U and also vector V. Find a vector which is perpendicular to both vectors with a magnitude of 3. So in these questions here, please be careful. Where when the time you read these questions here, if I just want to find a vector which is perpendicular to both of them, it can be easily found by either you using vector U cross with vector V, or the other way around, or you can use V cross with U. Salah satu pun boleh, tak ada masalah. However, this cross product, it does not necessarily happen to have the magnitude of square root of 3. And how we happens to do something so that I have this cross product to give me a magnitude of 3. So guys and girls, in here, what I will suggest you to do is that, let us have the idea is that, first, we find out what is happened to be either one of these. Then we consider finding the corresponding unit vector. And why I want to consider unit vector is because the unit vector always have a magnitude of 1. And then what I do the next is that this unit vector, we multiply with the scalar of square root of 3. That will be the result we have. So in my solution here, I begin the calculation with the cross product. The cross product is actually the determinant, so make sure you take notes of the bracket. It's a straight line bracket like modulus. The first row, I have ijk, and be aware, in here, I'm doing in typing, so my vector, I happen to have the letter written in bold. But when the time you write vector, dalam tulisan tangan, this sepatutnya, contohnya, vector I, it should have a curly line below. So in order to make sure you're alert, later all the vectors I will be highlight in red for you to see. For example, these are vector. So nanti you pastikan dalam tulisan Anda you ada curly line di bawah. Okay, so I'm using U cross V. Kalau you tak suka U cross V, the other way around pun tak ada masalah. Kalau U cross V, the second line will be U, 1, 2, minus 3, followed by V. By the calculation of determinant of 3 by 3 matrix, this is what I happen to have for my result. So this is the vectors that I happen to find out that is perpendicular. So saya sudah capai bahagian sini. Next, what I do is that this vector that I find out, it doesn't guarantee that I have magnitude of square root of 3. So what I need to do the next is that I try to find the unit vectors of this cross product. In order to get the unit vectors, I find the magnitude, I find the norm, where the norm is that I take each of the coefficients ijk, I square it, sum up, and then the whole thing I square root. And this gives me a result of square root of 181. And in here, please don't convert into decimal, leave it in square root form. Then follow. For the case of unit vectors, by right, what I do is that I will consider vector U cross V divided by the norm of U cross V. But I doesn't show this calculation here yet, where I'm just going to direct do these two in one on the next line. And let's say I make one assumption. I call that W is the vector which is happen to have the criteria perpendicular to both of them and also have the magnitude. How can I achieve that is that, let's see carefully. I'm going to have the unit vectors where we have U cross V divided by the magnitude. And then we multiply with the magnitude we want, square root of 3. And by the way, I've forgotten just now. I did mention just now, Later, whichever part that is happen to be vector, I will highlight it in red. So let me highlight those is happen to be vectors in red, so that you alert that these are the things that you should have curly line below it in your writing later. Tolong jangan boldkan dia bila you tulis sebab tak nampak dia adalah vector kalau you boldkan dia. But instead, so these happens to be the terms that we are going to return as vector. And then as a result, this is the answer I have. The square root, I'm not able to simplify it in this form here. And this is the final answer we have. Go on, part B. You are given vector A and B. A is equals to 2i plus j plus 3k. B is equals to 4i plus 2j plus mk. Find the value of m if vector A and B are in two different situations, if they are perpendicular, if they are parallel. So guys and girls, if let's say they are referring to perpendicular, should be equals to 0, where 0 is happen to be a scalar lah, bukan vector. Of course, you terbalik B dot dalam kiraan, tapi di sini saya buat A dot B saja. Or maybe I state juga, atau ini pun boleh. Whereas kalau parallel ada banyak properties, ada 3 properties kita boleh pakai, but among the 3 properties, I'm going to make use of the easiest one, where the A and B, they are scalar multiple of each other. Where, for example, I have A equals to T times T, where T is a scalar, or I can have B equals to T times of A, where T is a scalar. And of course, the T in these two situations, they happen to be different value. Or maybe in order to make sure you don't get confused, I change another scalar, let's say lambda. Okay, now we start from the part 1, perpendicular. We know that the dot product equals 0. So what we do now is that we substitute our vector A and B. And in here, once again, I'm going to highlight those terms is happen to be vector, where I just bold it only in my typing. Beside that, make sure you remember to have the dot there. Dot product. With the result of dot product, this is the result I have. First term, 2 multiplied 4, 8, plus with 1 multiplied 2, plus with 3 multiplied m. And this is equal 0. Just simple calculation. You should have m equals to negative 10 over 3 as your result. Okay, go on. If let's say the case of parallel, so we are going to consider the case that they are scalar multiple of each other, where this is my assumption. I let A equals to TB, where T is a scalar. I need to mention T is a scalar. So this is the statement to implies that they are scalar multiple of each other. Then with that, I substitute accordingly. Vector A and vector B multiply with T. Next, be aware, in order to solve your value of m, I need to find out what is the corresponding value for t. And in order to solve t, you can make use of the first or the second value in this matrix here, which is the component for I or component for j. And between the component I and j, I will choose the easier one. I will refer to the component j, where I have 1 equals to t multiplied 2, so 1 equals to 2t. Of course, if you compare using the component I, you will get the same result again. This one is referred to component j, from component j. If you make use of component I will give us 2 equals to 4t. And at last, they will give the same result, t equals to 1 over 2. And once again, before I go on further, vector A, vector B, Make sure you have a curly line below the letter A and B. Then follow. With the value of T found, we make use of it to find out the M, where you of you have 3 equals to Tm. And substitute the T that we found just now, 1/2, and you get your M equals to 6, as simple as that. Next, given the straight lines L1 and L2, find the angle between L1 and L2. So let's just try to have a simple drawing to see what is going on here as our strategy to solve. Let's say this blue line here, I have it as L1. Then I have another green line. I call it as L2. The angle between the two lines, usually in drawing, we will just happen to label this angle lah, this part here, the acute angle. But take notes, sometimes the angle that you calculate out happens to be obtuse angle, we don't know. So if let's say you find out that the angle you calculate is happen to be greater than 90 degrees, it's all right, because in your calculation, you happen to calculate the obtuse angle here. Okay, go on. In order to calculate the angle between L1 and L2, we are not going to use the full equation of L1 and L2, but instead, we are going to refer to their corresponding direction V, where in this case here, my L1, I have a vector V, which is happen to be parallel to it, whereas for L2, I have another free vector, which is happen to be parallel to, and the angle, again, it can happen to be this angle, the acute angle, or it can also happens to be, if I extend these three vectors here, it can also happen to be the obtuse angle here. So the red and the red, they have the same size. The purple and the purple, they should have the same size. And from this form here, the parametric form, we're able to identify out what is happen to be our value of V, where how we happen to get the answer of our V for each L1 and L2 is that we refer to the parametric equation where we have x minus A1 over V1 equals to y minus A2 over V2 equals to z minus A3 over V3, and this corresponding V1, V2, V3 will happen to give us the direction. Of course, with the condition, make sure the coefficient of x, y, z is happen to be 1 lah. So in this question here, memang coefficient dia lah 1. Jadi kita boleh terus belasah untuk L1, 3, 1, minus 5 for V1, V2, V3, which is the corresponding IJK as stated below. Similarly, L2 also, coincidentally, all the coefficient for x, y, z is 1. So I can terus belasah the denominator, 1 minus 1, 1. Then continue. In order to calculate the angle, we're going to make use of the formula. We are going to make use of the formula that we derive from dot product, where theta is equals to the arc cos of, let's say in this case here, we're referring to the vector of V1 and V2. So we have V1 dot V2 divided by the V1 multiplied with the norm of V2. So with the formula, as we can see here, in order to get the angle, I need to find out the dot product and also the corresponding norm. So to get the dot products, this is the result I have, -3. So to get the norm of V1 and V2, I find out that V1, I have square root of 35. V2, I have square root of 3. And as a result, when the time I and I press calculator, I have the answer as 107 if I correct to 1 decimal for my answer. So by right, it's good enough to keep your answer until here. But just in case, if let's say the question want to have acute angle, so if I want to have acute angle, happen to be taking 180 minus 107. So it should have the answer as 72 degrees. Kalau mau acute angle lah. Tapi soalan tak minta acute angle. It's alright to state as 107 degrees. And in here, I miss out the definition of the theta, where the theta is the angle between the two lines. This between L1 and L2. Angle between L1 and L2. Okay, go on. Number 5. We have random variable questions here, where you're given, luckily, you're given cumulative function direct. So less trouble we have if you have the cumulative. First, calculate the median. So in the case of, if you want to find median, that means we are going to refer to the parts that we have our f equals to 1/2 or 0.5. And is m, so refer to fm equals to 1/2. In this case here, if you refer to this piecewise function of the cumulative, the possible location of our median is either the second or the third. It cannot be the first and the second because for the first, fm is 0, the second, fm is 1. But we want 1/2, so it's between 0 and 1. Where in between 0 and 1, we only have two functions as our choice. And between these two functions, which one is supposed to be the location of our median? This is the part that we need to consider and investigate. And in order to do that, we start from the second interval. We consider substitute 1 into the functions. We consider substitute 1 into the functions, and let's see what's the result that we get. And we try to compare with 1/2, whether it's greater, less than, or equal to 1/2. If equal to 1/2, then just nice. We have identified what is the median. But if let's say we don't get 1/2, we get more than or less than 1/2, then we have to make other conclusion for that. So with a quick substitute inside, we have a simple calculation as f1 equals to 1/3. And we notice that this result, 1/3, is obviously less than 1/2. f1 is less than 1/2, and from f1 less than 1/2, we can tell is actually our median doesn't located in this interval highlight in blue. And if not this interval highlight in blue, then your only choice that you can have is located in the third interval, which is the one that I highlight in purple now. So therefore, we come up with the conclusion that if m is our median, median is happen to be this interval. Do 3, include 1, doesn't include 3. Then, after we find out this, so what? What we're going to do now is that we're going to refer for our capital F for the interval from 1 until 3, which is the one that I highlight in purple now. I'm going to substitute all the x with m. And the calculation will happen as follows. I found out that if after I simplify, I will have a quadratic equation in such that I have m squared minus 6m plus 6 equals 0. do is that first we try to do factorization. If possible, we factorize to get answer. If not possible, we apply quadratic equations. And then we solve to have two possible answers. In this question here, it doesn't specify that they want how many decimal places, so I keep the answer in three significant figures, 1.27 and 4.73. And then from there, we decide which one's supposed to be our answer. So based on what we find out just now, we have that since we want this interval for m, therefore our answer equals to 1.27. In other words, we reject 4.73. Follow? Part B. We want to find the probability for P modulus x minus 1 less than 1 over 2. This question here, what I'm going to do is that I'm going to make use of the cumulative, and you can only make use of the cumulative function, the capital Fx, to find the answer. You shall not refer to the PDF where that is going to found in the part C. So you mesti ikut flow dia. Mesti cari daripada cumulative, baru go to part C. Bukan pergi part C dulu, jump balik ke part B. And by the way, before we can do any calculations, let us define the modulus. Let us define the modulus in the questions. So if I have modulus less than, and the modulus here I have in front of it, it doesn't have any negative sign. Recall back on last semester knowledge. This is what I happen to have for the definitions. The terms at the middle, x minus 1, I want to get rid of the minus 1. So each of this part here, I'm going to plus 1. And this is the result I have from 0.5 until 1.5. Up to here, if I want to use cumulative function to solve for this case, what I need to do is just that I use capital F of the value behind that you can see 1.5 minus the capital F of the value in front, which is F 1.5 minus F 0.5. And where to get my F 1.5? So 1.5 is located in the function I highlight in purple now. Whereas 0.5, I'm going to substitute into the function I highlighted in yellow now, where they corresponding to the interval we want for 1.5 and 0.5. So we substitute. So again, this is the one that I highlight in purple. The other one in yellow. And this will give us the final answer, 13 over 24. Keep in fraction form so that this answer will happen to be the more accurate answer rather than decimal. Continue. Part C. We would like to find the probability density function, the PDF for x. So what we know is that from cumulative, if I want to find PDF, I will differentiate the cumulative function. So in my calculations here, what I'm going to do is that I will just, in my next line here, do differentiations in the cumulative function. So see properly in my solutions here, where I will consider the first interval in my cumulative, x less than 0. When the time I differentiate constant 0, I got 0. The next one, from 0 until 1, differentiate x over power of 2 divided by 3. I got 2x over 3. Next one, from 1 to 3, include 1, doesn't include 3. Function is x minus x squared over 6 minus 1 over 2. When the time I differentiate, I have 1 minus x over 3. Lastly, x greater than 3. We have constant 1, differentiate constant, we get 0 as well. So I have done the differentiations, but this is not yet the final answer because I would like to simplify the part that is redundant, where I have the function as 0. Dua-dua ada kosong sini. Dan dua-dua ada kosong ini, I can combine them into 1, which is otherwise. And then the rest of the 2, just copy balik saja. And be aware, saya sedang dapat result untuk small letter f sudah. Sini adalah small letter f, tapi saya tak tulis. So this is how I get the answer fast enough. Then the last part on question number 5, we want to find mode. So to find mode, in this case here, the mode will refer to the highest point of the f. In other words, we can try to observe from the graph of this fx here to know the highest point. So guys and girls, by the way, kalau you perasan, maka dia satu saja. So by right lah, dia punya answer sangat simple. There doesn't involve a complicated calculation. So in this case here, let's just try to see how we can get the answer. Okay. First of all, if you notice, dia punya interval dari 0 sampai 1, 1 sampai 3 for your small letter f. Then both of the function we have is a straight line function. So kalau saya cuba sketch satu graph, yang graph ini saya sketch secara belasar saja, dari 0 sampai 1, 1 sampai 3. Ini graph yang secara kasar. Dia bukan graph sebenar, secara kasar untuk tahu macam mana dapat jawapan. So from here, we know we have 2x over 3 from 0 to 1. That means kan, apa akan berlaku kalau saya sketch this graph here is a straight line graph, where we notice that the coefficient of x is a positive value. Jadi ini adalah graph yang naik, straight line naik. So therefore, maybe there's something like this. Tapi dia tak boleh include 1, dia include kosong. Then the other side, I have 1 minus x over 3. So graph ini sepatutnya graph yang menurun lah. So I suspect lah dia akan something like this maybe. Atau di bawah saya tak pasti. So I need to confirm in the way that I try to calculate out some value in this graph here. Try to confirm the value of y on these 2 points here. When the time I cuba substitute masuk dan cuba compare. And also I try to calculate this point here. Tapi by right you tengok idea di sini kan, dia akan perasan mode is the highest point of your graph. By right, based on this rough sketching here, saya tahu saya tak perlu consider this point x equal to 0, because for sure ada banyak point lagi tinggi daripada dia. The same thing go for x equals to 3, saya tak payah consider. I just need to consider about this one, x equals to 1. Sama ada dia terletak di bawah ke atas, saya tak pasti, but kita cuba kira. And by the time you substitute 1 inside, you substitute 1 inside, you also have 2 over 3. So they don't have the same value, and we find out that the one that gives 2 over 3 is 1. So that goes our answer. Of course, if you want to further enhance your answer to check, you boleh substitute jugalah the endpoint value inside the straight line equation. Cuba tengok setiap satu endpoint value you substitute into your straight line equation, which one is happen to give you the highest y value. Then the x will be the answer we have. Okay, go on. Question number 6. So question number 6, we have a continuous random variable with the PDF as follow. This question is difficult in the sense of we have an unknown constant there, where k is a positive constant. They want us to find the mean of x in terms of k. So don't be afraid of the k there. Always bear in your mind your k is a constant. So bila you buat integration pada constant, you should know what is the result you have. So the mean of x is that we're referring to ex, and how we calculate for ex in this case here is that, recall, kalau you nak kira ex, it will happen to equal to integration of multiply the PDF. From the infinity to infinity, where most of the time we don't write infinity, smallest and largest value that we have for non-zero function. So in this case here, when the time I want to calculate the EX, I will have integrate from 0 until k. So let's see. There's only one non-zero function involved here. The smallest value I have is 0, largest is k, integrate from 0 to k. And I want x multiply fx. This is your fx. When the x, you see that dari 2 dia jadi 2x. And next, creativity lah to perform the next calculation. But let's say I perform in the way that I expand and simplify dulu. So I expand 2x multiply k divided by k squared. I have 2x over k. Again, don't forget your k is a constant. The other one, if I expand, I have minus 2x squared over k squared. When the time I integrate, I find out that 2x over k become x squared over k. 2x squared over k squared become 2x cubed over 3k squared from 0 to k. By the time I substitute k into these equations here, I find out that the result will give me as k when the time I substitute k. Saya dapati the function give me the result of k. I just cut short the calculation sudah lah. When the time I substitute with 0, saya silap lah. When the time we substitute with k, we get the answer as k minus 2 over 3k. When the time I substitute 0, when the time I simplify my answer, I have 1 over k as the mean. And this is the answer we want, where we answer in terms of k. Dia tak ada exact value, but written represent by k. Next, we would like to show that the standard deviation of EX is equal to k over 3 square root of 2. And before we go on further with the calculation, let's see what is the actual thing that we want here. Where we want the standard deviation is actually referred to square root of variance. Square root of variance. And what is actually variance referring to? Variance is actually referring to the expected value of x squared minus the square of expected value of x. So in this formula here, in order to calculate standard deviation, we happen to find out that we have the EX, but the thing is missing is the EX squared. So before we can get the answer for the standard deviations, let us try to calculate for our EX squared. So this is happened to be the result we have. When the time you try to calculate EX squared, you multiply x squared with your PDF, integrate from 0 until k. Then again, up to your creativity to do the integration. But for me, before I integrate, I expand and simplify. Then when the time I integrate, these are the following result that I have. Again, when the time you substitute k into the function, this is the result I obtain. When the time you substitute 0 into the function, this is the result I obtain. Then I have 1 over 6k squared as my EX squared. Up to here, we just find EX squared only. We want standard deviation. So how we get the answer? So as we say just now, standard deviations is actually square root of variance. And if I substitute the variance, it will happen to be EX minus the square of EX. So kita substitute nilai yang kita ada, square root of EX squared minus square of EX. And when the time you simplify the answer, you have k over 3 square root of 2. Okay, kalau you tak pasti macam mana dapat jawapan, biar saya buat step itu dengan detail sikit sebelum dapat jawapan. So by the time you simplify, you have the answer as square root of k square over 18. Square root of k square, I get k. Saya terus k saja. Over square root of 18. Square root of 18 is the same as, I can come square root of 9 multiply square root of 2. Square root of 9, it gives me the answer 3 square root of 2. And those of you who square root of 18, you can direct get answer 3 square root of 2. Okay, go on. Next. Find the probability such that I have x less than mu plus sigma over mu plus sigma multiply square root of 2, where your mu and sigma is referred to mean and also standard deviation. Jadi part C, I need to make use of my previous result. And make use of the previous result when the time you substitute, the probability now is turned out to become something like this. I substitute my mu. I substitute my standard. And by the time we simplify, I have x less than 2 over 3k. I integrate my PDF from 0 to 2 over 3k. I expand and simplify, get this function first before I integrate. Then I integrate, substitute. This is the result that I find. Happen to be disappear along our calculations. So the answer is 8 over 9. Last questions. 7a. 7a, the question seems to be redundant, but never mind. Let us different patterns of asking the similar job we want to do. You're given, in part A, you're given the diagram as follow, where show the normal curve, where this is a normal curve, where this part here is referred to the mean, the mu, and we have region A, region B, with the corresponding value of x as 6 and also 12. And by right, ini diagram ada saya rasa di mana sepatutnya lah sini kita tak boleh label sebagai fx lah, which is the y-axis lah, sepatutnya tak boleh label lah. Okay, but anyway, it doesn't affect a lot lah. Okay, so this is what happening. The mu is happen to be the axis of symmetry of this bell-shaped diagram here. So what you happen to tell us is that, according to these questions, let us try to see. You was told that the region, and what is this regions of A is actually probability of x less than 6. You want to put less than equal to B. The other one, 0.3. So which means that the B is actually Px greater than 12 is equal to 0.3. Then next, they want us to find out what is the mean and also variance. So the means, kita nak cari mu sama dengan berapa. The variance, sigma square berapa. And in order to get the answer for this case here, let's see the following solution. So we start with the unknown, the distribution with unknown parameter mu and also sigma square. From the information just now, this is what I have. X less than 6, 0.6, 0.4. X greater than 12, 0.3. So what we do the next is that we do standardization. 6 minus mu over sigma equals to 0.4. Up to here, after you have done your standardization, guys and girls, the next step, to get the next step result, I would suggest that whenever you siap you punya standardizations, cuba kita observe mana kedudukan untuk kita punya 0.4 di sini, or the probability here. So, how we observe? First, you tengok less than beritahu kita luas kawasan di sebelah kiri of your bell-shaped diagram, and sebesar mana? 0.4, kurang daripada 0.5. Jadi kalau untuk standard punya sini adalah kosong, then your corresponding 6 minus mu over sigma adalah di sebelah kiri, dan luas kawasan dia adalah di sini, 0.4. And you notice that this diagram here in green tak boleh pakai statistical table. Yang boleh pakai statistical table dengan syarat dia, saya ada region di sebelah kanan, juga 0.4 luas dia, and the corresponding Z value will happen to be with the same magnitude 6 minus mu over sigma, tapi opposite sign. And as a result, if I expand this negative sign here, it will happen to give me mu minus 6 over sigma. So please be aware lah, ini adalah kawasan yang warna biru di sini. Then from statistical table, for Z greater than 0.25, I happens to have approximately equals to 0.4, the exact value, but it's just approximately. Compare this part here with 0.25. I have the result, mu minus 6 over sigma is 0.25. Then there I form equation 1. Similar idea, for x greater than 12 equals to 0.3. I continue with standardizations. Then observe, I have greater, I have 0.3. So in this case here, the region is smaller than 0.5. That means it will be, let's say, somewhere here in red. And the corresponding Z value will be 12 minus mu over sigma. And these regions here, we can get the answer from statistical table. So from table, out that for Z greater than 0.252, the probability is almost same as 0.3. Again, I don't get the exact value, but I get the approximate value with the Z at 0.52. Compare these two I highlighted in yellow. I'm able to form the second equation. Next, what we do is that we just happen to solve the two equations. You'll get the answer of your sigma and mu, and there goes your answer for mean and in here, there is a remark for you to take notes. For those of you using the table in the last page of your statistical table, by right, this is the corresponding answer that you have lah. Okay. Last question, nothing much different. Last question, nothing much different. But now, the last question, we have some story there. You was told that the mass of guava in a farm is normally distributed. So from there, we notice that this is corresponding to the X in our discussion later, where X will follow normal distribution, such that a mean of mu and a standard deviation of sigma. So again, parameter hilang. But what we know is that the mass percentage of guava less than 400 gram is 15.87%. More than 500 gram is 6.68%. Part 1, find out the parameter mu and also sigma. So how are we going to do that? You will see the calculation is similar like just now. It's just that now we have some meaningful definitions on our X, where this is referred to the mass of guava in gram. Again, parameter mu and sigma don't know. We need go on. First info, the mass is less than 400 gram. So we have the percentage as 15.87. If we convert to probability, we have Px less than 400 equal to 0.1587. Then if more than 500, this is what we have, more than 500. And now we tackle one by one. Less than 400, those standardizations. Have a quick check on the regions. Let's see the regions here, 0.1587 is located at where? So we see less than, we see sign less than, region on the left. The value is less than 0.5. That means it will happen to be somewhere on the left here. So this will be my 400 minus mu over where this region is 0.1587, the size. This region cannot use statistical table. I want to find the corresponding regions on the right, which also give the same value. And this corresponding Z will be, I consider this value with opposite sign. And as a result, this is what I have. The blue region will be happen to be, I happen to have Z greater than negative of the one in red here. So as a result, I have mu minus 400 over sigma. Once again, from statistical table, this time I can get exact answer where Z is greater than 1. I happen to form the following equations, similar like just now. Compare with 1. The other side, we do the same thing, standardizations, observe, more than 668. If refer to the diagram, more than, it will be these regions here, where we can get the answer from statistical table direct. And this is the result we have for equation 2. Once again, by simultaneously, you solve equation 1 and equation 2. There goes your answer for mu and also sigma. The question asks for sigma as final answer. Finally, the last part. We want to find the probability the guava has a mass of at most 500, given that it's more than 400 grams. So this is actually a conditional probability where more than 400 is the condition. And under this condition, we want to find the probability at most. So as a result, if I write in conditional probability form, on top, I will have 400 until 500 between the one in blue and the one in yellow. Then up to here, what you do the next is that, guys and girls, please be aware. You see carefully on my solution on the next part here, what I do. The next part, you notice, I doesn't do any standardization. But instead, what I'm doing is that I happen to have 1 minus this situation here. So what is happening here? Why I'm doing this? Why I'm not doing the standardization? If you happen to notice, this is because kalau you perasan, first of all, the denominator, I buat 1 minus. 1 minus p x less than equals to 400 is equivalent to px greater than 400. The reason I do 1 minus here is because I want to achieve x less than equals to 400 here. And in this case here, if you notice, this is a continuous case. So for the case of less than equals to 400, it is equivalent as the case of x less than 400. And why I so eager to get x less than 400, the probability of x less than 400 is because, if you notice, let me highlight this part here. Ini sudah ada jawapan dalam soalan yang kita perasan tadi. Let me erase the unnecessary trace just now. We happen to find out from the questions where we have less than 400, we have the percentage as follow, and this, it happened to provide us the result just now that we state px less than 400 is 0.1587. So therefore, whenever I see the case of having x less than 400, the probability, I will substitute direct. And you will see that in my solution later, for the denominator, you akan saya terus substitute nilai. Saya tak buat standardization because ada previous result. Whereas on top tengok benda yang sama berlaku kalau you perasan case of x less than 400 pun saya substitute dengan p less than 400 so that I boleh substitute nilai 0.1587. And before we go on further, how I get my result just now on the numerator atas ini. So guys and girls, although ini belum standardized, but we notice that this is happen to be the case of mean. And based on our calculation just now, we happen to know that our mean is 440. Our mu is 440. Then what we have is that we want 400 until 100. So let's say this is what we have from 400 until 500. So this is the region we're referring to, although belum standardized lagi. So in order to get this region shaded in red, we will take overall minus tempat yang kosong. So tempat yang kosong adalah bahagian yang sekarang saya highlight dengan warna hijau. Where hijau pertama di sini adalah 1 minus px less than 400. The other one will be greater than 500. And with that, this is how I achieve my answer as following. And why I want so eager for x greater than 500? Because again lah, maklumat yang sedia ada tadi. So I substitute without doing any standardization or statistical table reference anymore. I can get the answer as follows. So therefore, that's it lah, our discussions for the set paper for KMS. It seems that I exceed the time 8 minutes out of 2 hours, I think 9 minutes. So anyway, that's all for today. Thank you very much for watching. Bye-bye.